So, good morning, everyone. Yeah. So, we will start from where we stopped out yesterday, which is understanding the type of threats and attacks that we can have in our networks. So, these are the types of threats that can actually pose vulnerability or threats to our networks. The first one is spoofing, right? So basically, spoofing is an attack with the goal of gaining access to a target system using a falsified identity. And this falsified identity can be another person's IP address, or another person's MAC address, or username, right? They will pretend that they are someone else. They will behave like a legitimate user, by using that person's identity. And the identity can be in form of the person's IP address, the person's MAC address, the username of that person, or the system names. Right? They will use that person's identity to commit crime on the network. So basically, that's spoofing. Then after spoofing, we have phishing. Phishing is an attack that attempts to misdirect legitimate users to malicious websites through the abuse of URLs or hyperlink in emails could be considered phishing. So basically, phishing is a malicious, message that will be sent through an email to your staff or a user, trying to lure them to do some malicious activities, but it will be in form of email, right? Then we have denial of service attack or distributed denial of service attack, DOS or DDoS. So a denial of service attack, I think we talked about this yesterday, but let's take it again. A denial of service attack is a network resource consumption attack that has the primary goal of preventing legitimate activity on a victimized system, right? They will not allow the authorized users to get access to services at that particular time. They will make sure the network is down so that legitimate users won't get access to that resources at that particular time that they need that resource. But DDoS, right? Like you say, it uses botnets, a group or a network of let me say attacked system on the internet, right? They will use them to attack a service or a network that they want to actually get access to. So basically, denial of service attack is just like an attack using a single system. Like it can be the attacker system itself. They will just use it to actually cause that disruption. But in DDoS, they are using a lot of system on the internet to perform that attack. Not a single system. They are using multiple systems to perform that attack. So attack involving numerous unsuspecting secondary victim systems, like hacked system on the internet, right, are known as distributed denial of service. And all those systems are called zombies or botnets. Yes, so they will use them to perform that action. Then we have virus. So the computer virus is perhaps the earliest form of malicious code to plague security administrators. As with biological virus, computer virus have two main functions. The first one is that they propagate and they destroy, right? So a virus is a self-replicating piece of code that spreads without the consent of the user, but frequently with their assistance. So basically, you just see a name and you click that name, or you will see a software and you download that software, right? But that software or that name may have some malicious intent embedded in it, right? So But virus cannot actually launch itself. You have to click. The user have to perform some actions before a virus can actually perform its intent. So we have worm. The difference between worm and virus is that worm doesn't even need your input. They will just propagate through your network. They will jump from one system to another system to another system without you clicking anything. But in virus, you have to click. You have to make them work. But worm, you don't need that. They will do it themselves. So they contain the same destructive potential as their malicious code object with an added twist. They propagate themselves without requiring any human intervention. They will just, crawl all over your network, from admin to user to staff to HR to, they will just be going like that. As far as all of them are connected to the same network, one will find its way. So all the systems on the network. Then we have Trojan, or we can call it Trojan horse. It is named after the ancient story of the Trojan horse. So basically, the Trojan is a software program that appears benevolent but carries a malicious behind the scene payload that has the potential to wreak evil on a system or network. Basically, you will think they are legitimate software. In your mind, you will be like you want to download Call of Duty, right, on the internet. It's a game normally, but you won't see any phishing or any abnormal activities in it. We just download it, but something is going on at the background. So it's not legitimate software. It's not a legitimate link. They are malicious. They can cause havoc to your system, but they will pretend as if they are legitimate software, but they are not. So basically, that's the brain behind Trojan. Okay, for example, ransomware often uses a Trojan to infect a target machine and then uses encryption technology to encrypt documents, spreadsheets, and other files stored on the system with a key known only to the malware creator. So basically, that's how ransomware works. Immediately they have access to your file, they will just encrypt all your files. They have the key, right, to that encryption. So basically, if you pay them, if they ask you to pay ransom for them to release your file, after paying, then they'll give you the key to decrypt that your files. Then we have on-path attack. In an on-path attack, attackers place themselves between two devices, right? Often between a web browser and a web server, to intercept or modify information that is intended for one or both endpoints. Just how man in the middle work, right? Then we have side channel. A side channel attack is a passive, non-invasive attack to observe the operation of the device. Methods include power monitoring, timing, and fault analysis attacks. Then we have advanced persistent threats. So basically, advanced persistent threats, they are actually a group of threat actors that have experience. They have sophisticated tools. Whether you like it or not, they will hack you. I don't want to know the security tools that you have. They will hack you. They are good. Like that's what they are born to be. They will hack you. There is nothing you want to do. They will hack you. And if they hack you, they can sit in your network for 10 years without you knowing that they are in your network. They are nations, nation attackers, states, wise attackers. They are sponsored by government, by states, by nation to perform that action. Maybe they want to hack Russia. They can't go to any, cybersecurity guy. They have some mad people in place that they are paying them salary. They are giving them everything they want. Their job is to hack, and they are good at it. And they have all the tools in this world that they want to use to hack. So don't tell me you are one company. You don't have the two they have. So they are going to hack you. They are going to hack you. So that's advanced persistent threats. They are a group of people, right? So they refer to threats that demonstrate an unusually high level of technical and operational sophistication, spanning months or even years in your network. They will just sit in your network until they see. This is it, right? Say they want to actually steal sensitive information that they know that in 10 years it will come to your network. They will sit in your network for that 10 years. And when that sensitive information comes, they will just steal it and they will go back. Without you will not even know that they're hacking, right? They will not, you will not even see anything, you know. They will play their part, you know, everything, plain. You won't know. So apps attacks are often conducted by highly organized attackers. So we have insider threats. Insider threats are threats that arise from individuals who are trusted by the organization. They are the staff of that organization. They work for that organization. And they have some level of authorized access to infrastructure, to the assets of that organization. But basically, maybe they are disgruntled employees or employees involved in espionage. Maybe they want to sack that employee. And, you know, we actually hear the incident of MTN now. The whole thing was caused by one of the staff that they want to let go. And he just decided to, to discipline them. So that's example of insider threats. Because he has authorized access to do that. It's not an attacker from outside groups. He worked in that organization and he wanted to discipline them. And he caused that havoc. So that's an example of insider threat. He may decide to steal their money if he has that access to. Or may even decide to give some attackers the information they need to hack them. So insider threats are not always winning participants. A trusted user who falls victim to a scam could be an unwinning insider threat as well. Maybe they send an email, like a phishing attack, right, to a staff. And the staff, because he or she doesn't have the idea of what he or she is clicking, mistakenly click a malicious email. So the person is still an insider threat, right? But it's not like he or she willing to do it, but at least he clicked that link. Then we have malware. So a malware, or the full meaning is malicious software, right? So it's called malware. They just shorten it to be mal and ware, but it's malicious software. A program that is inserted into a system, usually overtly, with the intent of compromising the confidentiality, integrity, or availability of the victim data. Application, it can be application or operating system, or otherwise annoying or disrupting the victim. Basically, it's just a malicious software that if you download, it can cause problem to your network or to that organization. It's malicious, so you don't download it. Then we have ransomware, right? A ransomware is used for the purpose of facilitating a ransom attack, right? Ransomware attack often use cryptography to lock the file. When we are talking about cryptography, we are talking about encryption and decryption of a file on an affected computer and require the payment of a ransom fee in return for the unlock mode. So they will hack you. It can be any attacker. They will hack your sensitive information and they will ask for money. That if you want us to actually give you back this file, send us crypto, using these accounts. Then, because they cannot use normal access or TT back, they will chase them. And, so they are using crypto nowadays. So they will send their crypto, their wallets, then they will pay money. And after paying money, they will give them the key to unlock the files. But they have to pay ransom before they can give them that sensitive data back. So let's check how to identify threats and tools that is used to prevent them. So here are some examples of steps that can be taken to protect networks. If a system doesn't need a service or protocol, it should not be running. You don't open port 80 when you are not using it. An attacker can use just log into that port. For example, I showed you the port here yesterday, right? This port, it carries some services or protocol ports, right? That's how it works in normal router and switches or servers. Those ports have their number. If you are not using them, you can shut them, you can lock them. Physically, if you have like a visitor in your company, they just see the wireless, you can just plug their cable, right? They will plug their cable to the system and they will start doing everything they want to do. But if it is logical, like we said yesterday, ports, they use numbers, right? Like port 80 for HTTP. If you are not using those ports, don't open them. Shut it. Okay, let me give you an example of what I mean by that. I think I downloaded Zenmap the other time. Let me see. So this is Zenmap, but normally it is Nmap, network mapping. So basically, it's used to find the open ports of vulnerabilities in the network. So in this case, you find the target. For example, let me see. Let's say this worldwide or global. Let's just use this. So you can actually find a vulnerability in any company using their IP address or the domain name that they use to represent their IP, their server or anything. You want to actually find the vulnerability. So if you do Aptech, Aptech, is it global? Yes. Still scanning. So I don't know why it's taking time. We'll come back to it anyway. So basically, it's used to find the open ports in a network or a vulnerability in your network. So like we said yesterday, we know that port 80 is not safe, right? So there are some organizations that is still using that port. So that means they are vulnerable to an attack. So if an attacker sees that port 80 is open in your network, they can exploit that port to hack you, right? So basically, I don't know why this is not working. This is not, it's taking time. So basically, you can use that network mapping, Nmap, to check, to find the vulnerability in the network, right? And from there, you can, from the results, right, you can decide if the organization is insecure or they have some, unsecure ports in there. You can hack them through that, through that vulnerability in their network. So basically, attacker cannot exploit a vulnerability in the service or protocol if it isn't running on the system. The port that you are not using, close it, shut it down, right? So in networking, there is a way we can actually shut all these ports, all these open ports. There is a way we can shut them, right? I will have to authenticate these wireless ports. Then I will lock it down so that if any visitor or, and basically this can be an employee as well that will decide not to have access to these ports, right? Is in the organization, we can lock that port so that if you try to connect to this port, you won't be able to. So, but if it is logical, if it is number, like you are trying to authenticate through the number, like port 80, port 21, all those ports are not safe, right? We can shut them on the network. So also we can use firewall, right? Firewalls can prevent many different types of attacks. So we have network-based firewall that protects entire networks in an organization, right? It's a centralized firewall, right, in an organization. It looks or it filters all the traffic in your organization, right? Everything that is going on in your organization, there is a centralized location whereby admin people can see the flow of the traffic in that organization. So with that network-based firewall, and it can be hardware as well, it can be software. But for host-based firewall, they are the firewall that comes with our systems, right? They are host-based because they are inbuilt into the system. They are software inbuilt into the system. So that one just protects the individual system, that particular system. The host-based is protecting this particular system, that firewall. So we have two types of firewall. We have network-based and the host-based. So network-based is mostly used in an organization, big organizations. It can be hardware and it can be software. But the host-based is in all of our system. Our system has firewall inbuilt in them. It is called host-based firewall. So these are the tools that we have. We have IDS, intrusion detection system. Basically, this tool is basically used to detect any abnormal or anomalies in our network. It will detect it and send a message to the admin that something is not normal. To send an alert to an admin that something is not normal in the network. Will you take a look? But the tool doesn't have the capability to find a solution to that problem, right? Then we have host-based IDS. So this host-based IDS, it monitors activity on a single computer. It is host-based. That means it is installed on one particular system to monitor that system alone. Then we have network-based IDS. So that one is going to be a centralized, IDS that monitors all the activities that is going on the network. So that if there is any anomaly on the network, to send that anomaly to admin in charge, that the traffic is not normal. Normally, we don't have this kind of traffic in our network, but I'm seeing something different, something that is not normal in the network. So this is it. Take a look at it. Then we have SIEM. So SIM is basically security information event management. It's a tool that gathers log data from different sources across an enterprise to understand security concern and apportion resources. So basically, SIM is a centralized tool as well. If you have a file server, if you have a database server, if you have web server, if you have your system, everything you are using on the system, all the log, all the activities that is going on in those systems or in those servers, they are going into SIM for normalization, so that the admin will not be checking each system one by one to check what is going on them. So this guy is going to actually, basically, they are deploying SIM using some agents. They will install agents on individual systems, on staff systems, a software agent. Then this software agent, we have like a server where the admin can monitor everything that is going on in that agent installed on every devices on the network. So something that is going on my system will be logged on the SIM, so that an admin doesn't need, imagine you have like 100 staff in your company, and the admin needs to check all the devices to check whether there is any abnormal thing going on your system. It doesn't make sense. It will take a time. But with the help of SIM, right, everything that is going on that system or the web server are going to the SIM server automatically. So then we have anti-malware or antivirus. So they seek to identify malicious software or processes. That's what they do. They fight malware or virus. Then we have scans. So these scans evaluate the effectiveness of security control. So example is the NMAP that I wanted to use the other time. Let me check. So the example is the NMAP or ZMAP. So basically the CLI is NMAP and the GUI is called ZMAP. So we've talked about firewall. We have firewall, the filter network traffic to find any malicious activities. Then we have intrusion protection system. So intrusion protection system, it works like an IDS, but it can also detect and prevent any abnormal activities on your network. IDS can only detect, but IPS can detect and fight it as well. So if you don't have IDS, you can use IPS, because IPS can also function as IDS. It can protect and also detect any abnormal activities on your network. So basically, this is just the explanation of the whole thing. So basically, it's just to detect. So we move on. So intrusion detection and prevention refers to capability that are part of isolating and protecting a more secure or trusted domain or zone from one that is less trusted or less secure. This is a natural function to expect with firewall, for example. We have types of IDS. We have host-based, right? They are installed on an individual system. That's host-based. And we have network-based. They are centralized software or hardware that is used to monitor all the activities that is going on in your organization. So basically, host-based intrusion detection system. So the host-based intrusion detection system monitors activity on a single computer, like I said, including process calls and information recorded in system, application, security, and host-based firewall logs. This can often examine events in more detail than a network intrusion detection system, because it is installed on your system. It can actually find everything that is going on your system more in depth than the network, right? because the network base will do some filtering, or some normalization, some aggregation. So during that process, it's going to lose some sensitive data as compared to the host base that is installed on your system. Then we have network intrusion detection system, basically. A network intrusion detection system monitors and evaluates network activity to detect attacks or event anomalies. It cannot monitor the content of encrypted traffic, but can monitor other packet details. A single network intrusion detection system can monitor a large network by using remote sensors to collect data at key network locations that send data to a centralized management console. Basically, they are talking about the agents that I said. So the agents will be installed on your system, just like we are trying to install Microsoft, or we are trying to install any software on your system, right? So they will deploy all those agents to the staff of that organization. And that agent will be the one carrying all the traffic that is happening on your system to the SIM, to the network IDS. So from there, the admin can just go to that place and check everything that is going on the network. So we talked about security information and events management, SIM. So it is called SIM, but it is security information and event management. That's the full meaning. Security management involves the use of tools that collect information about the IT environment from many disparate sources to better examine the overall security of the organization and streamline security efforts. Like I said, it's going to collect logs from different devices on the network to a centralized location where an admin can just go to and check everything that is going on the network. The general idea of a SIM solution, right, is to gather log data from various sources across the enterprise to better understand potential security concerns and apportion resources accordingly. So SIM systems can be used along with other components, e.g. defense in-depth, right? You can use SIM as a defense in-depth as part of an overall information security program. So this is how to prevent threats, preventing threats. So, like you said, you have to keep system and application up to date. When you see patch, Tuesday patch from Microsoft that install this patch on your system, and you decide to ignore, don't worry, don't do it. The body will tell. So basically, you keep your system up to date. You patch your system. When there is new updates, make sure you apply it to your system. I know some people that they don't apply updates. They be like, it will crash their system. Are you kidding? So it's because they've seen some vulnerability, something is going on. So they decide to make an amendment, right? Like 0-day exploit. We have 0-day exploit, whereby it is new. So all these antivirus, anti-malware, they don't have the signature inbuilt in them. So it is new to them. They cannot fight it. They cannot defend it. It's a new disease that there's no dose for it, right? So it is a vulnerability in all the system at that particular time until an amendment is made. And that amendment will be sent in the form of an update. Microsoft will be like, update your system. You will see the notification that you should update your system. And if you decide not to update it, and if they hack you, so that's not Microsoft problem, because they tell you to update, and you decided to ignore. So vendor regularly release patches to correct bugs and security flaws. But this only help when they are applied. If you don't apply it, you are at your own risk. Patch management ensures the system or that systems and applications are kept up to date with relevant patches. Remove or disable unneeded services and protocols. We talked about that the other time. So imagine a web server running every available service and protocol. Obviously, it is vulnerable to potential threats on any of these services and protocols. We are running port 80 that is insecure. So that means an attacker will just use that port to hack into your web server or your network. We are using FTP instead of SSH. They can actually take that opportunity as well to log into your system easily. Use intrusion detection and prevention system. You use IDS and IPS on your system. So intrusion detection will detect vulnerability or anomalies on your system. And the intrusion prevention system is going to prevent or fight it for you. We get that? Then use up-to-date anti-malware software. There are some malware or antivirus that are up-to-date, but in your mind, you are still using antivirus, but it's up-to-date now. It's out of date. So basically, yes, it's not, that antivirus itself is virus. Since it is not up to date, it is virus on itself. It's added to the vulnerability on your system because you don't update the patch. So attacker will use that vendor, that version of the antivirus to hack you. Because the vendors release patches because maybe somewhere the attacker will find some way to actually hack that vendor. And they will fight it by releasing patches so that it will thwart the attacker. But you didn't apply the updates. So that means you are still vulnerable on the internet. So use firewall as well. Firewalls can prevent many different types of threats. Network-based firewall protects entire networks, like you said. And host-based firewall protects individual systems. Your system, my system, they are host-based firewall. They use host-based. There is antivirus. Using antivirus products is strongly encouraged as a security best practice and is a requirement for compliance with the Payments Card Industry Data Security Standard, PCI-DSS. So basically, PCI-DSS is a standard, that all the banks or all the companies that are in charge of payment cards must follow and obey. So because this standard have some policy in place that they must follow. And if you don't follow it, if an attacker hack you, they will sue you because you don't follow that protocol. They will believe it's because you don't follow it. That's why you are able to hack you. So PCI-DSS is a standard that's applied to people that issue payment cards. There are several antivirus products available, and many can be deployed as part of an enterprise solution that integrates with several other security products. So antivirus system try to identify malware based on the signature of known malware. This is how antivirus works. Maybe from the past attacks that has occurred in one particular company, right? They will take that signature or the sample, right? Or the artifact of the attack that one particular company finds. Maybe China have their signature that if China hack you, there are some signs that you know that, okay, this attack is from China or this attack is from Russia, right? They will collect that sample and vendors in charge of antivirus, they will use it to apply some rules to the firewall that we see this kind of signature, block it because it is malicious. So don't accept it. So that's where the concept of 0 day comes in because they've not actually applied the signature to the firewall or to the antivirus. So firewall cannot fight it. It doesn't have any experience that this disease occur until it now spreads and the vendor that are in charge of antivirus software now see the signature, they can now apply it and send it out to all their products. So immediately you apply. So that means, anytime that 0 day is coming to your network, the antivirus will fight it for you. because it knows that it's malicious already. But before then, they'll be able to penetrate because the antivirus doesn't even have any idea of what is coming to the network. We have scans. So like I said, the scan that I wanted to show you the other time will be like this. So, for example, if you want to say you want to actually check if one particular organization is vulnerable to any type of attack, right? Let's say maybe you want to check their database, right? To see if you can, hack them through their database. You just find the IP address that is mapped to that database. For example, say that IP address is 172.20.1.131. Sorry, I think we talked about IP address yesterday. Man, what type of IP address is it? What class of IP address is 172.20.1.131? Don't check your book. Don't check. Just stand like that. You can't see it. This is it. Don't worry, I'll show you. Yeah. 172.20. No. We talked about classes of IP address yesterday, right? So what class? Are you sure? Are you sure it's classes? Okay, you're not in the class yesterday, so I can ask. Okay. No, but you didn't tell me that you didn't hear me well. So I'm asking you. But you didn't tell us yesterday that we can't hear you well. So that means you're in the class. What kind? If not answer me now. You said class C, right? Okay. So what class? No, you you said you're in the class. Whatever. So what you? Oh yeah, what type of B? Okay, B. Yeah. No, him. He was in the class. See, two of you. Class. There's nothing. It's what? C. C. What class of IP is that? Okay. Class B. So you want to try? There's no trying. Yeah, in my networking class. Yes, no. Yeah. Ha. Okay. Because the number is not here. Don't worry. So okay. Wait. Class. No. What's the range of class A IP address? The range of class A IP. It's not about cramming. What's the range of class A? Are you sure? It's 0 cents. 12126. 12126. What about class B? What about class C? What about class D? 240. Okay, you are not in my class yesterday. Okay. Okay. So basically, you have to get used to it. So in this type of resource now, we can see that port 80 is open. Open port, discover open ports. Port 80. TCP is open on port 80. And we all know that port 80 is not secure. Right? So using this, we can hack the company. Just find an exploit that speaks to port 80 in a web server, and boom, we are in. We can have access to everything their web server. Because it's port 80, it shouldn't be open. They should close it down since it's not secure. So open it, make you give access to an attacker to come in. It's like an open door. All these ports that are like open door to your company. And you know that this port 80 It's not secure. So why do you let it open? So the open port must be closed. Even 21.2 is open. FTP, File Transfer Protocol. But 21. It's not secure and it shouldn't be open. You should close them. Okay. Okay. Is it open to? Is it possible to? Yes, yes, that's what I said. There is a way. Yes, yes. There is a way you can lock it so that if you plug a cable, your LAN cable to this port, so there is a way you can configure this router in such a way that even if you plug your cable to it, it will not work. Yes. Okay. Okay, the Zema. Yeah. Of the, yes. You can use any of them. DNS will still, convert, the way we said the internet or the computer works normally, they don't understand English. So when you are using your CLI, you are typing google.com, so DNS will still convert it back to an IP address. So if you type the IP address to convert it, it will convert it back to an IP address for you. So it's either you use your IP address trace or you use the domain. If you don't know the IP address, you can use the domain. Then it will give you the same result. Yes, I was trying to use the Aptech domain the other time because I don't know the IP address. So you want to test on your system on network. You really know how to find out the IP address. Yes, if you know the DNS. So we can do for Google. Because that I'm not using my system. Now what I'm saying is I've configured this thing for you. No. The parrot. Yeah, yes. It's opened. Try to open it. Then we can try to actually practice, put in practice what I'm trying to say. You are able to actually open it. Yeah. Yes. Oh, it's not installed. It's not installed. Does anybody have like Ubuntu or anything on their system? No. Yeah. Ubuntu or Kali Linux. Yeah. Port 80. So basically, port 80 is just an unsecure way of browsing on the internet. It's still HTTP, Hypertext Transfer Protocol, like www. something. But if you use the unsecure, okay, let me show you something here. You will notice that, I'm not sure it is here. You will notice that most of the time when you are trying to browse, you will see one key. That's the secure part of the HTTP. Sometimes if you are trying to use unsecure, it will tell you that this site that you are trying to go, it's unsecure, and you will see the key cancelled. So that means everything you are doing on the internet at that particular time is in plain text, is clear. So it's everybody, if anyone is able to actually hijack your session, they can see everything you are doing on the internet. If you are transferring money, they can see it, they can see everything you are doing. But the secure version, everything will be encrypted. to be jangled, like they won't be able to understand what you are doing. Or if it's plain text, to be like normal English like this, like hello, hello. But normally, we can see our WhatsApp like end-to-end encryption. So basically, we are able to sit in between two-person communication. You are able to filter what they are saying. You still will not understand what they are trying to communicate to each other. That's why it is end-to-end encryption. So if I sit in the middle like this and trying to see your WhatsApp chat, I won't be able to understand. Even if I'm able to actually, filter the message. That's the reason why it is end-to-end. But if it's not end-to-end encryption, so that means if I'm able to sit in between two of you, I can see your communication. Right. Yes, it is breakable. Yes, it is. You can break it. It all depends on the algorithm you used to encrypt that, communication. WhatsApp, yeah. It's been encrypted, we all know. Yes, it can. They can still break it. Yes, they can still break it. So firewalls. At least we've been discussing firewall. So in building construction or vehicle design, a firewall is a specially built physical barrier that prevents the spread of fire from one area of the structure to another, or from one compartment of a vehicle to another. Basically, that's the brain behind firewall. But they now used that concept in cybersecurity or networking, so that if you are coming with your rubbish, you will not come to this site. Right? So basically, let's go. So early computer security engineers borrowed that term for the devices and services that isolate network segments from each other as a security measure. As a result, firewalling refers to the process of designing, using, or operating different processes in a ways that isolate high-risk activity from low-risk ones. Right? They will detect the risk that is coming to your organization, and they will log it. They will tell you that something is going on in your network or in your system, and you will see the pop-up notification that what you are trying to download is not secure. So it will tell you. So it's not left to you to continue or to fight it. So basically, that's how firewall works. But firewall needs some rules, to be put in place. We call it explicit rules, whereby the administrator will be the one to configure the rules you want on that firewall. Like we said, most firewall and antivirus, they use signature-based. Signature-based in the sense that an attack has occurred in one company or one country or one nation or somewhere before. The firewall vendors, they will take that signature or the artifact and try to, implement it or use that signature to give the firewall a rule that if you see this kind of signature, it is malicious, block it. And sometimes you can use an IP address instead of signature-based. There are some IP addresses that are malicious, like the nmap, right? Nmap is malicious. It's not safe for an organization to see someone trying to scan their network, because they know that if you are trying to scan their network, it's possible that you are trying to find a vulnerability in their system. It's not legal, they catch you. They will catch you. But it's just that it is less kind of like a crime, right? You are still trying to hack them, but even though they catch you, because you are a risk to the organization. Like, why are you scanning our network? For what? We didn't give you the access or authorized to do that. So it is not permissible. But there are some organizations that put the security in place that when they see that IP address from Nmap coming to the organization, we block it. And there's still a way can still bypass that. Even when they block, it can still bypass it. Cyber what? Cyber law. Yeah. Okay. I mean, is it fully functional in Nigeria? I don't know anything that is functional in Nigeria. Maybe you can tell me one, then I can answer it. No, it's the fact. I'm not, but I don't know. You've answered your question by yourself. There's nothing that is functioning like that. Yeah, but yes, there are some laws. But Nigeria now, they will use SLA to pronounce. We now. But all those countries, they don't, even if it's Google, you will pay for the damage. But in Nigeria, you will see Access Bank telling you that they want to carry out some monitoring by 12 to 1 a.m. in the midnight. Why are you telling me? So that means you are telling me that will be unsecure for that period of time, right? Basically, that's what you are telling us. Why do you have to tell us? Just let people get there and see that the service is not operational. But sometimes it's good as well. Like we said, it is confidentiality, integrity, and availability. The system must be up and running most of the time. So they have to inform you that, okay, probably your service will not be available from this period of time, but it is as well unsecure in one part. But you are saying you are bringing that to service. So if you want to try us, you are free. Come up. By this time, let's fight. So we've talked about intrusion prevention system already. So let's move on. Then we have network security infrastructure. So we have on-prem data center. It is on-premises, but they call it on-prem, right? On-prem data center. So when it comes to data centers, there are two primary options. Organizations can outsource the data center or own the data center. So if the data center is owned by a particular company, it will likely be built on-prem within the premises of that organization. So a place such as a building, basement, or closet to house the data center is needed, along with power, heating, ventilation, air conditioning, HVAC, fire suppression, and redundancy. So basically, this is how on-prem data center works, right? So in your organization, you have your one particular place that can be a basement or anywhere where you put all your servers, your assets, most critical assets, you put them there. So you'll be running it yourself. You buy the server, you buy the computer, you buy the switches, the routers, everything you need. You buy it on your premises, right? So then you'll be running it from your office. And sometimes it can be outsourced. You give it to someone to help you monitor it. Maybe you are not capable or you don't have experienced, staff or employees that can monitor it, can outsource it to people. That please help us to manage this thing.
Are there data management organizations here? What I mean is this: organizations that help other companies to keep their data.
Yes.
Both physical infrastructure.
Yes. 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 MTN is doing it. Even government has their own. You will just go there, you will buy some space. They will give you the price, and you can put your data center there. But they will give you one place like this. It's just like a building. They will build it for people to come and keep their devices. So the security, the power, everything you need to run it, it will be on them. Then they will tell you that, okay, maybe it is monthly that you'll be paying them or yearly. So anytime you just want to do something there, we just drive to that place and do it. We have May 1 and 2. Just two, they are doing it. You know May 1. Yes. So they do that. As an ISP, when I was working as a network engineer, we have our own. So we have another one. It's May 1. And we just go there. And you can't go there anytime. You book an appointment. Even though you are the owner of that data center, you still cannot go there because the data center is not for you alone. There are a lot of people. You know, MTN is there, Glo is there, My Mobile is there. A lot of companies are there. So if you are going there, you book an appointment. And when you get there, you sign, register that you come at this particular time and you left at this particular time. So if anything wrong in the network, you are the last person that now imagine interrupt FCS service because you are trying to, do something on your data center. You mistakenly use your bag to remove one cable from MTN service. Now imagine they are losing millions of naira already. So they will just, when they come to that, maybe May 1 or any, they will just be like, we know the person. You will pay for it. So basically, we just pay like 150 million. They will not sue you. Sir? So we have power. So data centers and information systems in general consume a tremendous amount of electrical power, which needs to be delivered both constantly and consistently. Wide fluctuations in the quality of power affect system lifespan, while disruption in supply completely stops system operations. So some people, right, they go to those vendors because they know that they have 24/7 power running. But maybe they know that in their own data center, they are not capable of doing that. Right? But they know that in that place, the power will always be up 24/7. So some people will go there because of that, so that there won't be any disruption in the service that they are providing for people. We have data center or closets. The facility wiring infrastructure is integral to overall information system security and reliability. Protecting access to the physical layer of the network is important in minimizing intentional or unintentional damage. So proper protection of the physical site must address this sort of security challenges. Data center winning, right? A wiring closet may include the following: phone, network, special connection, ISP or telecommunication provider equipment. Those are the things that we can have in the data center. We can have servers too. We can have wiring or switch components in the data center. So then we have heating, ventilation, and air conditioning. So all the data center needs this. And your data center must not be too hot. And it must not be too cold too. And it must be out of dust and stuff like that. So basically, that's what heating, ventilation, and air conditioning is doing. They need to be in a well-conditioned environment where they can function properly. They are like brain. If your brain is hot, and inside some you will not perform, you will be malfunction. But if you are where the AC is cool, then you can function. Then we have fire suppression too. For server rooms, appropriate fire detection or suppression must be considered based on the size of the room, typical human occupation, egress routes, that means router is going out, and risk of damage to equipment. For example, water used for fire suppression will cause more harm to servers and other electronic components. But gas-based fire suppression systems are more friendly to electronics but can be toxic to humans. But it's still better than using liquid suppression in the data center. So it will cause damage. So these are components of on-prem data centers. Now that we've looked at some of the primary components that must be considered when building an on-prem data center, we should take a deeper dive into some of the components. The first one, okay, first, we consider the data center air conditioning requirements. Then another consideration for the on-prem data center is fire suppression system. We discussed about that too. So another hazard is having water overhead data center. Eventually, water pipes will fail and may leak on equipment. So you don't want to have them to your data center. Then we have redundancy. So the concept of redundancy is to design systems with duplicate components, right? So that if a failure were to occur, there will be a backup. So that means, all these Microsoft, Google, they have a lot of redundancy. They will give you a service and they will give you an option to have a backup plan that if this one fails, So basically the concept of redundancy is that you have the same services in two different places. So if one is done, so you can just pick the second one up. So without any disrupting the service. So this can apply to the data center as well. Risk assessment pertaining to the data center should identify when multiple separate utility service entrances are necessary for redundant communication channel and or mechanisms. If the organization requires full redundancy, device should have two power supplies connected to diverse power sources so that if one power supply fails, the second one can take it up. Maybe you have generator and you have UPS in place so that generator don't have fuel. The UPS can take it up depending the time you buy fuel, or you should have electricity and the generator in place. These power sources should be backed up by batteries and generators. In a high availability environment, even generator can be redundant and fed by different fuel types. So this is the example. We have UPS. We have transfer to switch. Okay, we can switch it to generator and so that generator can be using fuel or utility power. So just like that, either use generator, you use UPS, and you can use different type of generator. The one that is using fuel or the one that is using diesel, anyone you like. This is the example of redundancy. This figure illustrates how, in addition to keeping redundant backup of information, a redundant source of power to provide backup power. So if you have an uninterrupted power supply, UPS, it's also best practice. So transfer switches or transformer may also be involved. And if power is interrupted by weather or blackout, a backup generator is essential. Often, there will be two generators connected by two different transfer switches. These generators might be powered by diesel or gasoline, by another fuel source, such as propane, or even by solar panels. A hospital or essential government agency might contract with more than one power company and be on two different grids in case one goes down or out. Then we have MOU, or Memorandum of Understanding, or Memorandum of Agreement. So, as a lot of us, I think we understand MOU and MA. We can jump it or we should hit it. So some organizations seeking to minimize downtime and enhance business continuity and disaster recovery capability will create agreements with others. Two of them will come and agree on some particular things. They agree that if one of the parties experiences an emergency and cannot operate within their own facility, the other party will share its resources and let them operate within theirs to maintain critical function. This agreement may even include competitors because their facility and resources meet the industry needs. So two of them will be like, okay, fine. If we are running these particular services for the company, right? And maybe something happened to us, maybe they hack us or something, please, we need your service pending the time we solve our own problem. For example, hospital A and hospital B are competitors in the same city. The hospitals create an agreement with each other. If something bad happens to hospital A, e.g., maybe fire, flood, or bomb threat, or loss of power, hospital A can temporarily send personnel and systems to work inside hospital B to stay in business during the interruption. So the hospital have decided that they are not going to compete based on the safety and security. They are going to compete on service, price, and customer loyalty. This way, they protect themselves and the healthcare industry. So basically, they are running the same services, they are providing the same services, but they know that anything can happen anytime. So two of them will come into an agreement that if something happens to us in the future, please, we need your facility. Pending the time, we find the solution to our own problem. Then we have cloud. We have cloud computing. Cloud computing is usually associated with an internet-based set of computing resources and typically sold as a service provided by a cloud service provider. So CSP, cloud service provider, they are the one providing a computing service to individual. You know, you will buy, instead of physical switches and routers and servers, and you know, they are sending virtual data center to you if you want to buy. They will sell it for you virtually. You will not see it, but it will be operational. Basically, they themselves, they have it somewhere, but it's not your problem to know how they are running it. Just pay for them and they will run the service for you. So basically, that means you don't need to buy all these physical switches and routers and everything to set up your data center. They have it at their own end. Just pay. They will tell you that pay this amount of money, then all of the services you need will be up and running in no time. And they will give you login to all those services. Anytime you want to log into your service, you are free. It's up and there until you stop the service. So cloud computing is very similar to electrical or power grids. It is provisioned in a geographical location and is sourced using an electric means that is not necessarily obvious to the customer. You don't need to know. But when you want electricity, it's available to you via a common standard interface, and you pay only for what you use. You only pay for what you use. That's what makes it, you know, okay for people to use. You don't pay for what you don't use. And cloud. So in on-prem, whether you like it or not, you've gotten the servers, the hardware, and everything you need already. It's not left to you whether you are using it or you don't use it. But you have the option, right, to bring down your service anytime. If you don't use it anymore, if you don't want it anymore. Imagine during Christmas that your sales is always like triple or double of what you said normally, right? So you can just go to cloud service provider and tell them that, you know, during, you know, Christmas period, we have double or triple times of the services we have normal day. You want us to scale the service for us, right? And, you know, they will tell you that, okay, this will be the cost to scale the service, and boom, your service will be scaled. But in on-prem, you have to buy those hardware, all those devices that you will not need for the next year to come. You get? So that means it makes the pricing more flexible and, you know, okay for people to use. It is very scalable, elastic, and easy to use utility for the provisioning and deployment of information technology services. So there are various definitions of cloud computing according to the leading standard. A globally accepted definition for the term cloud is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources, such as networks, servers, storage, applications, and services. All of these cloud service will provide it for you, right? That can be rapidly provisioned and released with minimal management effort or service provider interaction. So immediately they scale it up for you, or they provision all of the services you need for you, right? You have the control now, right? You can decide to log into it. You can decide to, do anything you like to it. It's now your own until the MOU or the agreement between you guys is expired. So basically, these are the types of services that you can find in cloud computing. We have broad network access, rapid elasticity. You can measure services and on-demand self-service. These are the resource pooling. So we have software as a service, whereby they'll be giving you software like Microsoft does, your Microsoft Word, your Excel. You can access it on the internet, right? So that's a typical example of software as a service. You don't have it on your system, but you can access it on the internet. So that's an example of software as a service. We have a platform as a service. In platform as a service, you can, have an interactive screen where you can code, just bring your application and start coding. So it's an example of platform as a service, and we have infrastructure as a service where they're giving you your servers, your computing devices, anything you want. That's a typical example of infrastructure as a service. So we have software as a service or SaaS, we have platform as a service, PaaS, and we have infrastructure as a service. Then we have type of cloud computing. We have public, we have private, we have public and private, which is hybrid, and we have community, whereby two companies will come together to contribute money to run a cloud services. So then we have cloud redundancy, just like normal redundancy, anyways. So many organizations have moved from hardwired servers to operations that are run by closed or cloud-based facilities because they provide both security and flexibility. So nowadays, people don't buy switches and routers and all of those things again. They just go to Microsoft or Google or Amazon to provide them with, cloud as a service. They will give you. You don't need to buy tools and the remaining things. They will provide electricity, everything you want. See now, you don't need to run generator and stuff like that. Yeah, yes, now your infrastructure will be run. At least it will run based on electricity. No, even more cheaper. Even more cheaper than running it yourself.
No, it is the data center running now that will not be after operation, right?
If you want them to run after operation too, they can do it for you. They can do that for you. You want them to do that. They are doing anything on the cloud. Yes. So, okay. Okay.
It's kind of these cookies.
Okay.
Accepting cookies online, does it have any direct editing effect?
It does and it doesn't. It all depends. So that's why you have to read it before accepting. So some will tell you that, they are using the cookies to run their infrastructure. That is the cookies that we accept and they will use to run their servers and code. Because so basically they can now decide to use your details for marketing, to send to organizations. So you will see that some cookies will be denied. You won't be able to browse in their website until you accept that cookie. Yes. So basically they are saying that we don't provide this service for free. So you have to accept our terms and conditions first before you can run the service.
And sometimes you feel like whether you accept or not.
Yeah, whether you accept or not. Yes, now. Whether you accept or not, they will still steal your data if you want to. So cloud characteristics. Cloud-based assets include any resources that an organization access using cloud computing. So cloud computing refers to on-demand access to computing resources available from almost anywhere and easily scalable. So you can access it anywhere in the world when you're running cloud service or cloud computing. So organizations typically lease cloud-based resources from third parties. Among the benefits of cloud computing are usage. So most commonly, usage is metered and priced according to units or instances consumed. So usage also can be built back to specific department or function. So it's, the pricing will still depend on the usage, what you are using, right? The service that they are providing for you and how you are consuming that service. So it's reduced cost of ownership. There is no need to purchase assets to support the function, no loss of assets value over the time, and a reduction of other related costs of maintenance and support. So you don't need to do all of those. You don't need to be patching your servers. When the server blows up, you need to change it. When there's any damage, you have to call an engineer to come and repair it for you. So you're running cloud service. You don't need all of those. They will be to want to do that at their own end. So the reduced energy and cooling costs as well. In addition to savings, there is the green IT environment effect with optimal use of IT resources and systems. You can scale it up anytime you want as well. Allows an enterprise to scale up new software, database services or solution quickly and without having to install massive hardware. Right. So basically, those are the characteristics of cloud. You only pay for what you use. The cost is not that expensive as compared to running it yourself on-prem. And, you don't need that much energy. Like we said, running data center require a lot of energy. And you can scale up your services anytime you want, any time of the day. Then we have service model. We have software as a service. So software as a service, a cloud provides access to software applications such as email or office productivity tools. So your email, you are accessing your email via the internet or via the internet. So basically, it is software as a service. You don't have it on your system, you're accessing it in the cloud. An example are also office productivity like your Excel, your Office, your Words, and co. So software as a service has many benefits for organizations, which include but are not limited to ease of use. Along with this is limited or minimal administration. You don't need to hire new admin to monitor the whole thing for you. Automatic updates and patch management. Cloud service will be the one to apply the patches for you. You don't need to do that yourself. And also standardization and compatibility. All users will have the same version of the software used. It's not like someone has applied the patch and someone has not applied the patch. All of you will run the same, standard. Then we have a platform as a service. The cloud provides an environment for customers to use to build and operate their own software. So basically, you can go there and decide to code or build your application or build anything. We provide you that platform to do all of those. So platform as a service, a way for customers to rent hardware, operating system, storage, and network capacity over the internet from a cloud service provider. The service delivery model allows customers to rent virtualized servers and associated services for running existing applications or developing and testing new ones. So you can go there and do your waterfall, and we all know the terms now. We have, all of us are network Software developer. Apart from so we have infrastructure as a service as well. Infrastructure as a service is a cloud provides network access to traditional computing resources, such as processing power and storage. So you don't need that. We provide it for you. I'm sure we provide 3 buckets for you to store as much services as you want. Apple will give you, what did they use? Apple uses this, what's it called? iCloud. No, yes, there is, no. There's this particular storage that they use. So, AWS itself, they are cloud providers. They provide services as well. So these are the benefits of infrastructure as a service. Ability to scale up and down infrastructure service based on actual usage. This is particularly useful and beneficial where there are significant spikes and dips within the infrastructure usage curve. That's an example of you having more customers on your network, and you feel like the traffic is more than what the service they are giving you can actually take. You can go there, you can go to them and be like, you need to scale up your service because your service is becoming crashing every day. So you can retain system control at the operating system level. So these are the deployment model, how we can deploy your cloud infrastructure. It can be public. So public clouds are commonly referred to as a service that are commercially available for the public to purchase. You can go there, go to them and be like, fine, I want this, just give me. So it is easy to get access to public cloud. There is no real mechanism other than applying for and paying for the cloud service. Just pay and they will provide the service for you. So it is open to the public and is therefore a shared resource that many people use as part of the resource pool. A public cloud deployment model includes assets available for any consumer to rent or lease and is hosted by an external cloud service provider like Google, like Microsoft, like Amazon. Then we have private cloud. Private cloud begins with the same technical concept as public cloud, except that instead of being shared with the public, they are generally developed and deployed for a private organization that builds its own cloud. So basically, for the private, it will be built for a particular company, right? So the infrastructure, everything will be, will be custom to that particular company. This is what we do. These are the services we want you guys to be giving us. That's what they will be giving you. So organization can create and host private cloud using their own resources. Therefore, this deployment model includes cloud-based assets for a single organization. As such, the organization is responsible for all maintenance. So if it is private, right, you will be the one maintaining the whole infrastructure yourself, not the cloud provider in this case. So, however, an organization can also rent resources from a third party and split maintenance requirements based on the service model that they are giving them. Private cloud provide organizations and departments and their departments private access to the computing, storage, networking, and software assets that are available in the private cloud. So they are running private cloud, you can access the services through other means. Maybe, they will give you VPN to access it. But if you are public, if you like, go to your web browser and access it. If you like, access it through it. So we have public versus private cloud. Some learners find it difficult to distinguish between public and private clouds. In short, the difference between public and private cloud is based on who is allowed to consume the cloud resources, and if the resources are shared. So public cloud make resources available to several organizations simultaneously. That's the public. To create cost efficiency through economies of scale. This means that different organizations will share the same underlying resources for physical hardware, such as data storage device, memory, and CPU. All of them, they will share it. It's not like it is unique to them. So company A will come to them, they will give company A the service. And if company B too comes, they will tap the service from that pre-existing infrastructure to the company B. So conversely, with private cloud, the expense is typically higher per unit of compute, but the above mentioned resource example will not be shared across organizations. That is, resources are private or per organization. So they will give the organization what they want. Organization will buy the infrastructure, and that infrastructure will not be shared with anybody except that organization alone. So that's what makes them private. Then we have hybrid cloud. A hybrid cloud deployment model is created by combining two forms of cloud computing deployment model. Typically, it can be a public and a private cloud combined, right? So hybrid cloud computing is gaining popularity with organizations by providing them with the ability to retain control over their IT environment, conveniently allowing them to use public cloud service to fulfill non-mission critical workloads and taking advantage of flexibility, scalability, and cost savings that comes with it. These are the important drivers or benefits that comes with hybrid. The first one is retaining ownership and oversight of critical tasks and processes related to technology. So you will be the one in charge of all the technology. You can control it. You have control over it when you are running hybrid. Another one is reusing the organization previous investment in technology. You can retain control over most critical business components and systems, and also using a cost-effective means of fulfilling non-critical business function via public cloud components. Then we have community cloud. We have private, we have public, we have hybrid, and last one, we have community cloud. So community clouds can be either public or private. It can be one of the two. It's not hybrid in this case. What makes them unique is that they are generally developed for a particular community. An example could be a public community cloud focused primarily on organic food, or maybe a community cloud focused specifically on financial services. The idea behind the community cloud is that people of like minds, maybe you are selling fish, you are selling fish. No, we are cloud provider, you are cloud provider. We are basically doing the same thing. So two of us can gather together to share IT capability and services and use them in a way that is beneficial for the interest that they share. So basically, in community cloud, two companies doing the same thing can buy a service from the cloud provider. Since they are doing the same thing, they feel like they can share the resources and still be provided the same service. We have MSP, which is managed service provider. A managed service provider is a company that manages information technology assets for another company. They will manage your cloud service for you, basically. Small and medium-sized business commonly outsource parts or all their information technology functions to an MSP to manage day-to-day operations or to provide expertise in areas the company does not have. So organization also may use an MSP to provide network and security monitoring and patching services. Basically, what MSP does is that you decide to assign your cloud services or operation to them that help us to be managing this, right? Just like normal physical data center. So they will be the one in charge and monitor everything that's going on in your cloud service for you. So today, many MSPs offer cloud-based service, augmenting such as a service solution with active incident investigation and response activities. One such example is a managed detection and response service, where a vendor monitors firewalls and other security tools to provide expertise in triaging events. So they will be in charge of the security of that cloud. So you will outsource it to them to help you to manage everything that is going on within the service. So these are the common reasons organizations use MSPs. One, augmenting in-house staff for projects. Implementing expertise for a product or service. Payroll services, help desk service management, monitoring and responding to security incidents, and managing all in-house IT infrastructure. Maybe they are not capable of doing all of this, then they can outsource it to the third party that have the manpower to do it for them. SLA. I think we've talked about SLA. It's just the cloud version of the SLA. So basically, the SLA is an agreement between a cloud service provider and a cloud service customer based on the taxonomy of cloud computing, specific terms to set the quality of the cloud service delivered. So the purpose of an SLA is to document specific parameters, minimum service levels, and remedies for any failure to meet the specified requirements. So we have network design. The object of network design is to satisfy data communication requirements and result in efficient overall performance. Several elements that are considered when planning for security in a network include the following issues. Let's wait. So these are the security network that we have. We have network segmentation. So the network segmentation involves controlling traffic among network devices. Complete or physical network segmentation occurs when a network is isolated from all outside communications. So transaction can only occur between devices within the segment network. So basically, the brain behind the network segmentation is that, for example, this department is one segment. The next room is another segment. So anything that is going on in this department, the next one will not be able to see. So if they are attacking this department, so it will only be contained in this room and it will not affect the next room. So they will segment a network. So IT department, we have one segment. Network department, we have another segment on their own. Finance, we have another segment like that. So if they are hacking finance department, it will not affect network and it will not affect every other department. So it will only be contained in that department alone. We have demilitarized zone, DMZ. The DMZ is a network area that is designed to be accessed by outside visitor, but is still isolated from the organization private network. So you are coming to the organization to access their web server. So they've created one server already, right? That will be facing the public. So there is one server in between you and the organization, and there is this another critical server behind it. So you coming from the internet, you are only talking to this infrastructure, this server. So if you have this server, you still have this one. So that's the militarized zone. The DMZ is often the host of public web, email, file, and other resource servers. Then we have VLAN. VLANs are created by switches to logically segment a network without altering its physical topology. I don't think we have to go deep in that. There is a technical know-how to it. We have defense in-depth. We talked about defense in-depth the last time. That defense in-depth uses multiple types of access control in literal or theoretical layer to help an organization avoid monolithic security stacks. So they put different security, devices in place so that if they are able to actually attack one, there will be another one to fight it, another one to fight it before they actually get into the critical assets that they want to access. So basically, this is still talking about defense in-depth. Defense in-depth uses a layer approach when designing the security posture of an organization. Think about the castle that holds the crown jewels. The jewels will be placed in a vaulted chamber in a central location, guided by security personnel. The castle is built around the vault with additional layers of security guards, walls, and what's this? Moat. The same approach is true when designing the logical security of a facility or system using layers of security will deter many attackers and encourage them to focus on other easier targets. Basically, it will frustrate them to keep going because they know that when they hack one, there's still another security mechanism in place and they need to hack again. And they have another one to hack again. And they have another one to hack. So they will just leave the organization and go to somewhere else. I think these people, they have some things in place. So you can actually read the examples further by yourself when the thing is sent to you. We've talked about zero trust. Okay, if not. So zero trust. So zero trust networks are often microsegmented networks with firewalls at nearly every connecting point. They have their switch, they replace firewall. They have router, they replace firewall. Any of their devices in that organization, they will put firewall just simply because they don't trust anything that is coming or going out of that organization. They want to filter anything. They don't trust anything or anyone in that organization. So that's probably the meaning of zero trust. So zero trust encapsulates information assets, the services that apply to them, and their security properties. This concept recognizes that once inside a trust but verified environment, a user may have unlimited capability to roam around, identify assets and systems, and potentially find exploitable vulnerabilities. So for this not to happen, they are putting security mechanism in every point of their assets. So if you are accessing their database, they have firewall that will filter the traffic and everything you are doing. So zero trust is an evolving design approach which recognizes that even the most robust access control system have weaknesses. It adds defenses at the user, assets, and data level rather than relying on perimeter defense. In the extreme, it insists that every process or action a user attempts to take must be authenticated and authorized. So basically, that's it. Anything you want to do in that organization will be authenticated and be authorized. At every point, you are being monitored. Everything you are doing is being logged. Then we have NAC, or Network Access Control. So an organization's network is perhaps one of its most critical assets. As such, it is important that we both know and control access to it, both from inside and outside. We need to be able to see who and what is attempting to make a network connection to our network. Who is connecting to us, or who is trying to connect to us. At one time, network access was limited to internal device. So gradually, that was extended to remote connection. Although initially, those were the exception rather than the norm. This started to change with the concept of bring your own device and the Internet of Things. So bring your own devices. A company employed you, and they are like, you are free to actually work with your own personal laptop or your own personal phones. Because it also comes with vulnerability because they don't know, maybe your system has been hacked before coming to the organization, and you bringing your devices to the organization, it adds more vulnerability to their network. So basically, that means they can hack the organization through the network that you are bringing to the organization. So, and network access control device will provide necessary network visibility for access security and may be used for incident response. Aside from identifying connections, network access control tools should be able to isolate non-compliant devices within a quarantine network and provide a mechanism to fix the non-compliant elements. So network access control must be able to actually know the devices that are not secure or that are not compliant to the organization's policy. So, and also they should have a feature to actually fix that issue. So they will give you some hints on what to do in order to be compliant with that organization. So these are the possible use cases for network access control deployments. The first one is medical devices. We have IoT devices, BYOD, or bring your own device, mobile devices, which can be laptop, tablets, smartphones, and co. It can also be guest users and contractors. I think this is 1103. They're all tired already. 1101. Okay. You should stop here for today. Or you want to continue? We should continue. We should continue. We should continue. Should we? It's your decision. So should we continue? So should we continue? Shaming, don't worry about it. And so, but the time is up. We can do that. No. 9 to 11 now. The answer, we'll do it next week. So we should call it a day. Or we should continue. We should call it a day. Right? So that means that will be all for today. Thank you for coming. See you next week, Friday.